A problem is we want to check to see if two strings are an anagram. Um, Pretty straightforward. I don't think I'm going to use a visual for this. My first thought coming into this was you turn each string into a hash map or a dictionary. I'm going to write this in Python. Um, and you want to see if they have the same keys, the same length, I think, too, or the same length of keys. Then you want to iterate through one of the strings, like the first one. Um, and if those keys and values are the same, you don't want to delete. My first thought was to delete, but apparently you can't mutate a dictionary while iterating through it too, so we're not going to use that. If they have the same values, if they don't have the same values, just like if banana, or if one word has 3 A's and another word has 2 A's, that means they're not. So then you can just return false. And then that goes along with my original solution of mutating the dictionary, but you want to do that. So yeah, I kind of learned that little oopsie, but so my second attempt to it was, like I said, turn the strings into a dict, which I made a helper function, a string to dict that takes a string and turns into a dictionary hash map with the occurrences of each character. And after that, you just want to make sure this one right here that the length of each of the keys is the same. That means they have the same uh, letters, amount of letters in or symbols in a word, in a string. And if they don't equal, then you can return false. Then because one has an extra unique letter than the other. And also from there you can move on to iterating through the first dict. And then you want to say is if the first dict key is not in the dictionary too, then it can return false. So if one word has the letter K and it doesn't, then you can return false because that's not an anagram. And then lastly, the last check is to make sure they have the same amount of values for each dict. So if the first word has like 3 B's in it, the other one needs to have 3 B's. So if it doesn't have 3 B's or the same amount of characters, you can return false. If not, if you pass those two, those are kind of the rules of an anagram, then you can return true. So right here we have horse and shore, which are anagrams. So if you print it, it returns true. But if you do the word shorn, there's no N in shorn or in the horse, so you get false. So, and then another test would something be like we get shores. This, even though they all have make up of the same amount of or same letters, there's different quantities of S's between the two, and you get a false as well. I think that's like the naive kind of human heuristic of just like splitting things down and checking. There's a super easy solution of it's kind of a computer way of thinking it. Maybe of playing bananagrams, but all you do is you sort the two strings. So you, essentially, this is a high level. Well, then you just sort them, and if they're the same array, then you can just return that. If it's true, then it's true. If it's false, then it's false. Essentially, sorted is kind of like a high-level abstracted method, but I would think what it would do is turn each ASCII, turn the string into a list of strings, and then map over that array to a ASCII character, and then you sort that from there because you have to sort values, numbers, and then from there you can check to see if those two arrays are the same. And then the runtime of that is just linear because you're just doing constant work on each of the elements in the array, and then you're checking through it. And then we'll just support this shore and horse, it just returns true. If you have shorn, returns false, and then if you have shores, it should return false. Yeah, that's kind of the really simple, easy way to kind of thinking it, but and then the runtime of this is linear as well, because you're pretty much just iterating once through the dict, and you're doing constant work on everything else. But you have to have a little bit more memory in this version because you're constructing two hash tables or dictionaries, and then this also is linear, so you get a little bit more linear if in the hash table way than compared to the sorting array. But yeah, nonetheless, it's pretty simple.